Hello, everyone. This is Elisa Baum. I'm Precona's Director of Product Marketing. We'll begin in just a moment, but first I need to conduct just a bit of housekeeping. Could you please raise your hand using the hand icon in the GoToWebinar control panel to let me know if you can hear me? Let's see. Can I see some hands? Oh, thank you very much. There's some hands. Great. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on Precona's MySQL performance blog. In addition, a recording of this webinar and links to the slide will be made available to everyone within 48 hours, if not sooner. I'd like to thank you for attending today's webinar, Multi-Threaded Replication in MySQL 5.6 and 5.7. It's being presented by Precona architect Stéphane Combondon. And with that said, Stéphane, you have the floor.
Thank you, Alisa. So, hello everyone. As Alisa said, we will talk about multi-threaded replication, and the agenda for today will be, okay. So we'll start with a quick introduction about why my Oracle has developed multi-threaded replication in MySQL 5.6. Then we'll see, of course, the performance benefit that you may expect from that feature. Then we'll take a look at some, let's say, day-to-day routine DBA stuff. So, for instance, how does multi-threaded replication work with GTID, and a few other things like that. And we'll also take a look at the new features of MySQL 5.7 regarding multi-threaded replication. So let's start with the first part, which is why multi-threaded replication. Well, if we first look at the good old replication, we have first on the left of the diagram the application. The application writes on the master, and as MySQL is multi-threaded, several concurrent connections can write at the same time on the master. However, when it comes to replication, so when you're on the slave, there is only one worker, one replication thread that can execute queries on the slave. So we may quickly have a problem. We can have multiple writes in parallel on the master. However, on the slave, the writes are serialized. So the idea is that with a few prerequisites in MySQL 5.6, we can allow the slave to be multi-threaded as well. So it will be a bit different from the master because there are a few requirements, but the idea is that we can have probably performance benefits by trying to commit several transactions at the same time. So first, let's look at the prerequisites. In 5.6, the idea is that we will use one worker thread per database. So we suppose in 5.6 that if you want to use multi-threaded replication, you must have several databases. And there's one extra condition, which is so for the transactions to be executed in parallel, cross-database transactions are not allowed, which means that if you're doing cross-DB transactions from time to time, that's not really an issue. If you're doing that a lot, you won't be able to benefit from the multi-threaded replication in 5.6. So, of course, the first prerequisite is having several DBs. So if you have all your tables in a single DB, that won't work for you, right? If you have 2 DBs, you can use 2 parallel workers. If you have 10 DBs, you can use 10 parallel workers, etc. So the main setting here is slave underscore parallel underscore workers, and you can set it to the number you wish. So it's I think the maximum is 1024. Not exactly sure about that, but that's still a lot. If you're using, for instance, slave parallel workers equals 10, and then you run show process list, you will see the 10 threads in the process list. So how does it work? Let's say you have a slave with 2 databases and 2 worker threads. So the first thing is that the IO thread will copy the bin logs from the master to the relay log. And then instead of having the SQL thread in the good old replication looking at the relay log and executing the transactions, you will have a coordinator thread that will simply look at the transactions and try to dispatch the work to the worker. So here you have 2 databases, 2 workers. So the coordinator will try to dispatch the work across these 2 workers. Okay, so that was the basic facts about multi-threaded replication. So now let's try to look at the performance benefits. Of course, when we talk about performance benefits, benchmarks, etc., it is not possible to test every workload, every combination. So my idea here is to try to see if in some very simple cases, multi-threaded replication can help reduce replication lag. I've done two tests. So the first one is a test where I'm using 2 databases and the master will write equally on each of the databases. And the second test will be a test where one database, say DB1, will get 80% of the writes. So the idea is in the first test we are in the ideal situation. So 50% distribution of the writes. It should be you should have the best result with that. Now the second scenario is something less optimal, so probably something that is more, but what we will see more frequently in a production workload. And for the test, I've used, of course, one master and then 3 slaves. The first slave is simply a single-thread slave, so it is only here to have the baseline. So what single-threaded replication can do compared to multi-threaded replication. And then I have 2 other slaves, one with 2 parallel workers, which is, let's say, logical because we have 2 databases, and another one with 50 parallel workers. So the idea of the slave with 50 parallel workers is simply to try and see if having much more workers than compared to the number of databases could introduce some performance degradation. So in the diagram you have the topology. So the master control slave is the slave with no parallel replication, and then the 2 slaves with multi-threaded replication will be named MTS 2 workers and MTS 50 workers. All the tests have been conducted on Amazon EC2. I've used M3 Xlarge instances. You have the settings that I've used. Basically, I've set a buffer pool that is large enough so that the test is run in memory, and I've used InnoDB flush log at transaction commit equals 1 on the master because it's typical, and 2 on the slaves because again it's typical. And I've used GTID replication. You have at the bottom of the slide the command line that have been run. So basically, I'm trying to insert 100,000 rows into 16 tables in DB1 and in DB2, and I have 15 concurrent threads for each database. Now let's look at the graphs. The first graph is how many writes we can execute. So the blue line is the master. So we can see that the test ran for about 3 minutes, 180 seconds, and of course the slave, so the control slave, the slave with no parallel replication, the orange line is not able to keep up. So we see the insert rate, which is approximately, let's say, 50% lower than the insert rate on the master. And of course, if we look at the slave lag, it's not good. So nearly instantly, the slave begins to lag, and what you can see is that the test on the master took 3 minutes, but it takes nearly 6 minutes for the slave to write all the transactions. So of course, this is not very good. Now let's look at the slave with 2 worker threads. So that is the green line. And what you can see is that it's much better. So the insert rate is, let's say, quite similar to the insert rate of the master. So sometimes it's lower, sometimes it's higher, but overall, the slave is almost as efficient as the master. And if we look at the replication lag, well, the difference is, of course, striking. So while the single-threaded slave was lagging a lot, the multi-threaded slave with 2 workers is almost not lagging. This is very good. Now let's look at the slave with 50 workers. So what we can see is that, so this is the purple line, the pink line. We can see that the insert rate is, again, approximately the same as the insert rate of the master. So this is good. So we can expect that the replication lag is approximately 0. And yeah, that's the same thing. So one interesting thing is that it seems that for this workload and maybe this specific test, the slave with 50 workers was slightly more efficient than the slave with 2 workers. This is probably something I should look at. I should investigate, because there's no good reason for that, because I only have 2 databases, so having 2 workers or 10 workers or 50 workers shouldn't change anything. Okay, so that was for the first scenario. Let's look at the second scenario. So this time, as I mentioned before, we have the same configuration, the same server. However, now DB1 gets 80% of the writes. Let's see what happens. So we have the same colors. So the master is the blue line, and of course the orange line, the control slave, so the slave with no multi-threaded replication, is again not as good. This is expected. But now the main difference is that the multi-threaded slaves are not able to keep up. And this is not really surprising, because as the distribution is 80% for one database and 20% for the other database, it is clear that we have far less opportunity for parallel applying. So of course we're between lots of parallel applying and single threaded replication. So that's why we have worse result than before. And if we look at the replication lag, well, of course, it's not as good as what we had for the first test. But if we compare that to the single-threaded slave, this is still much better. So the lag is not increasing as quickly, and overall, the replication throughput is much higher. So the main conclusion of that part is, as expected, that your mileage may vary, but the more the closer you are to a fair distribution, that means equal right distribution across all your databases, the more efficient multi-threaded replication will be. And of course, I think I could have done a test with, let's say, one database receiving 99% of the writes. In this case, of course, you will be very close to single-threaded replication. Okay, so let's now talk a bit about some operational stuff. Like, for instance, how do we skip replication errors when we have multi-threaded replication? Does multi-threaded replication play well with GTIDs, etc.? First thing to know, so I'm assuming here that GTIDs are not used. And I'm interested in looking at how positions are monitored, because you have multi-threaded replication, so several worker threads can commit events in parallel. This means that you don't have a single, let's say, latest executed position, but you have several ones, say one per worker thread. And one thing to know is that as the worker threads commit events in isolation, you can have execution gaps, meaning that the relay log is not replayed in order. So of course, the execution gaps are tracked so that from time to time, the slave is able to perform a checkpoint to make sure that a transaction is not left behind and everything is still correctly executed. Regarding checkpointing, you have two settings to tune, let's say, how often they will happen. That's basically slave checkpoint period. So how much time between each checkpoint, and the second one is slave checkpoint group, which is how many transactions are allowed to execute before one checkpoint is executed. Let's talk a bit more about execution gaps. So on the left, you have the relay log, and you have the transactions. We can see that we have transaction 1 and transaction 2 that will apply to DB1, and then transaction 3 that will apply to DB2. So when the coordinator thread reads the relay log, it will see that transaction 1 and transaction 3 can be executed in parallel. And by doing that, you will create an execution gap because transaction 2 will be left behind. It will be executed after transaction 3, right? And this is where checkpoints are important. They make sure that from time to time, we know that all the transactions up to some point have been executed. So back to the positions. It's quite common to look at the exec master log pos field in show slave status to know where the SQL thread is up to. However, with multi-thread replication, this field is no longer, you can no longer be, trust it, because it will only show you the position of the latest checkpoint. So it doesn't show you the latest executed position, only the latest checkpoint. And this has an impact. We'll see that in the next slide. One question is, okay, so we have execution gaps, but sometimes we may need to make sure that we don't want to have execution gaps. So we need to make sure that they're all removed. Can we do that? Yes, you can do that. You can run stop slave and then run start slave until SQL after MTS gaps. If you do that, it's really like performing a checkpoint. So all execution gaps will be removed. So be careful that stop slave alone is not enough. It will work in most situations, but there are cases where it will leave execution gaps. You have the bug number if you want to have a test case. I mentioned before that exec master log pose is no longer reliable, which means if you look at show slave status, you can't really know the latest executed, the position of the latest executed transaction, and that may be a problem. The first problem you can have is when you want to skip a transaction. When you run set global SQL slave skip counter equals 1, what it will do is basically change exec master log pose to the next position. However, as this is no longer the latest position, it is not guaranteed to work. It is not guaranteed to skip the transaction you want to skip. So if you want to skip a transaction, basically you have to first make sure that you have no execution gap. So you have to run stop slave, then start slave until SQL after MTS gaps, and then only you can run set global SQL slave skip counter equals 1. So, well, you have to be careful. Same thing if you want to take a backup from a multi-threaded slave. When you take a backup, you need to have the binlog, the corresponding binlog position on the master. And to do that, what you do, you run show slave status and you look at exec master log pose. This will no longer work. If you do that, again, you have the position of the latest checkpoint, which means that if you restore the backup and restart replication from that point, you are very likely to have duplicate key errors because you will replay events that have already been played. So all in all, using multi-threaded replication without GTID may not be very practical. In theory, it is allowed. You can do that, but in practice, it's probably not a good idea. So the recommendation is really to use GTIDs, and GTIDs will solve all the problems with the positions simply because with GTIDs you have a new variable which is executed GTID set, and this one is reliable because it's updated each time a transaction is executed. Of course, if you try to use multi-thread replication with GTIDs and run show slave status, you may have some surprise, like you have this very ugly executed GTID set field with lots of information that are not understandable at first sight. So what does that mean? That's very easy. What you're seeing here are simply the execution gaps. So for instance, we can see that we had transaction 1 to 94998 that have been executed, and then the next executed transaction has the GTID 95008. So you have a gap of 10 transactions. So, well, that's fine. That's fine. And actually, if you run show slave status, let's say 1 second later, you will see that the execution gaps have moved because, for instance, one checkpoint have been performed. So instead of having a gap between 94998 and 95008, the first gap will be at, let's say, 95030, for instance. Okay. So I talked about the GTIDs with multi-threaded replication, and I think it's good to spend some time on GTIDs because it's a new feature of 5.6, and by experience I know that not everyone is very familiar with it. And if you want to use multi-threaded replication, frankly, you should look at GTIDs first. So what is a GTID? It is simply an identifier of a transaction. But the nice property about GTID is that this identifier is shared across all servers in a given replication setup. It means that if you have a transaction, it has the same identifier on the master and on every slave, which is very different from the positions that you can find in the bin logs or relay logs, which are, of course, different on every server. A GTID has two parts. The first part is the source ID, which is the server UUID, and then the second part is transaction ID, which is simply the counter. And of course, GTIDs are only available in MySQL 5.6 and following. The main benefit of GTID is that it's now really easy to change your replication topology because you don't have to look at to change to use the master log file and master log pose options in change master. You can simply use master auto position equals 1. So basically what you do is to say change master to master host equals the new master, and then master auto position equals 1. And then the master and the slave will, let's say, they will talk together and they will negotiate where the slave should start replication. So this is great. For failover, of course, this is very beneficial because it's simplified. Same thing if you have multi-tiered replication, it's much easier to manage. So if you have a relay master, so a slave which is the master of several other slaves, it's very easy if it fails to simply reconfigure the final slave to be slave of the original master. Be aware that GTIDs are not a high availability solution. GTIDs do not provide replication monitoring. So if replication fail on one slave, GTIDs will not solve the problem automatically. GTIDs do not provide failover. So if the master crashes, GTIDs will not be able to elect a new slave, to elect a new master, and reconfigure replication everywhere. You still need replication monitoring, you still need scripts to provide failover. However, they make high availability much, much easier, simply because the difficult part when you have to perform failover is handle the different positions everywhere. And this part is gone. A few other things to know about GTIDs. The implementation in 5.6 requires that you stop all the servers at the same time to enable GTID replication. And this is a hard requirement, which means that it is not possible, for instance, to turn on GTIDs on the slaves and not on the master, and then do a rolling restart or things like that. It doesn't work. So you have to stop all the servers at the same point in time, which means downtime, which is bad. So this is an issue for many people. In 5.7, I hope it should be improved. But if of course 5.7 is not yet available, so we'll see. And if you're using 5.6, you still have a few opportunities to enable GTID replication without downtime or without too much downtime. The first one is to use the latest Percona server, which has an online GTID rollout feature, which is a port from from what Facebook has developed before, and Booking.com has also developed another patch for online GTID rollout, so it can also be useful. One other thing to know is that if you enable GTID replication, you will need to have binary logging enabled on every server, every slave, and log slave updates, which means it will have some I/O overhead. In 5.7, if you have a slave that you will never promote to be a new master, you can disable binary logging. You have another feature that allows GTIDs to work. When you have GTID replication enabled, you have a few new columns in show slave status, mainly retrieve GTID set, simply the list of GTIDs that have been received by the IO thread, executed GTID set, which is the list of GTIDs that have been executed by the SQL thread, and auto position should be set to 1 if GTID replication is enabled. One very important thing to know about GTID is that the replication protocol has changed a bit, and it has some implications that not everyone understands very well. So what happens when the slave connects to the master? If you're using position-based replication, the master simply sends all the transactions from the given offset. That's very simple. With GTID-based replication, it's very different. First, the slave will send the range of GTIDs it has executed, and then the master will send back all the other transactions. And we have an additional rule, which is a given transaction. So a transaction with a given GTID can only execute once. So the good thing with this new replication protocol is that it allows auto-positioning, simply because the slave and the master will talk together to know which transactions the master should send to the slave. The bad thing is that it creates new challenges. The first one is how to skip a transaction. If you try to use set global SQL skip slave counter equals 1, it won't work. It will throw an error. And it's a good thing that it doesn't work because of the new replication protocol. So if it worked, the thing would be that the transaction would anyway automatically come back as soon as you restart replication, simply because, well, again, when you start replication, the master will send all the transactions that have not been executed. So if you say, oh, I want to exclude that one, it won't work. So the solution is to execute a fake transaction with the GTID you want to skip, because then we will benefit from the additional rule which states that a transaction with a given GTID will only be executed once. So if you execute a transaction, a fake transaction, which will do nothing, the slave will record that it has executed a transaction, and it will not ask the master to send it back again. So how to execute that fake transaction? You stop slave, then you set GTID next to the GTID you want to skip. You run an empty transaction, so begin commit, and then you set GTID next equals automatic, and you can restart the slave. And that's how you can skip a transaction. The challenge number 2 is errant transaction. So this is something that doesn't exist with position-based replication. So binary logging is enabled on all servers, including the slaves. So if you write directly to the slave, it will generate, the transaction will be recorded in the binary logs, and it will generate its own GTID. And because of the replication protocol, if the slave is promoted to be the new master, the transaction will be sent to all the servers. This may not be what you want. So basically, you have two situations. The first situation is that you intentionally wrote to the slave because you need to have a separate schema on the slave. If you promote that slave to be the new master, everything will be propagated, replicated to all the servers. So and you can't do anything to avoid that. Second problem that can be even more annoying is that if the transaction is no longer in the bin logs, the I/O thread of the other servers will try to get this transaction. However, it no longer exists. So the I/O thread will exit with an error, the 1236 error, and now replication is broken. So be very careful with that. It is quite frequent to see that problem. So how to deal with errant transactions? Basically, you have two functions, GTID subset and GTID subtract, that you can use to identify an errant transaction. So the idea is that the set of executed transaction on any slave should be at any point in time a subset of the executed set on the master. So this is how you can detect that you have an errant transaction. If you found an errant transaction, what you'll have to do is to skip it on all the servers with an empty transaction. And if you need to run local transaction on the slave, well, probably the best option is to use setSQL logbin equals 0 to make sure that the transaction will not be tracked in the bin logs, and so that it will not generate a GTID. Okay, so last topic for the day, the new things for MySQL 5.7. In MySQL 5.6, we have parallelization at the database level. However, it's not good for everyone. I mentioned at the beginning that if you have a single database, well, multi-threaded replication in 5.6 will not help you. In 5.7, you have a new type of multi-threaded replication which relies on a logical clock. The idea is that on the master, we can commit several transactions at the same time, so probably there is a way to also commit the same transactions in parallel, so at the same time on the slave. And this is something that we can do. So if we set slave parallel type equals logical clock in 5.7, we will be able to use, so on the slave, we will be able to use that new kind of multi-threaded replication. If you're happy with the multi-threaded replication per database, you can still use it on 5.7. Simply set slave parallel type equals database, which is the default. So how does it work? On the master, you simply have additional metadata that is stored in the bin logs, and that can be used to identify transactions that can be applied in parallel on the slave. And on the slave, the coordinator thread is able to read the metadata and then to dispatch these transactions across all the available workers. Another new and interesting thing in 5.7 is that you have much better replication monitoring. In 5.6, the only way you have to monitor replication is show slave status, which is okay for single-threaded replication, but it's not that good for multi-threaded replication. So let's say you don't use GTIDs, well, you have this exec master log pose field, which is no longer useful. It's still there, but it's no longer useful. That's not very good. If you're using GTIDs, you have this executed GTID set field, which is very ugly because you see the execution gaps. And there are things that are missing. For instance, you never know, for instance, the latest transaction executed by a worker thread. You have a field to store the last error that has been seen, but what if you have several threads having errors at the same time? You won't be able to see that in show slave status. So in an effort to overcome all these issues, 5.7 is now using performance schema for replication monitoring. The good thing is that this opens the door to a lot of new and exciting things, like you can run real queries, real select queries on performance schema. You can have much more granularity in your monitoring, so that's good. Of course, the main drawback is that using performance schema is always more difficult and will probably be always more difficult than using show slave status. The main issue is what we'll see in this slide. Instead of having a single location where everything is stored, show slave status, you have several tables. So you will have to figure out how to combine the tables together to extract the information that you need to have. But that being said, I think that's a really good step forward. So you have an example of one query, so you can see the status of each worker thread with the query I've pasted here. This is quite good in my opinion. Okay, so this is the end of the presentation, and I think we have some time for the questions. So Alisa, this is so back to you for the question.
Okay, great. Was there another slide? Yeah. Before we get going into the questions, and Stefan, there are so many, so we're going to get to as many as we can, and those that aren't addressed, Stefan will write a follow-up blog post on the MySQL performance blog. So our next MySQL conference for Kona Live is April 13th through 16th in Santa Clara, California. I wanted to call your attention just quickly to two things. We've just added a brand new track. It's called MySQL 101. It's 2 days. It's normally $400. First 101 people that register, special promotion, you get it for $101. And it's designed to take somebody who's not proficient in MySQL, like a database administrator managing some other kind of database, and turn them into a MySQL DBA. So if you or someone that you know is interested, get them to sign up right away, because for $101, it's kind of a bargain. The other thing is March 8th, advanced pricing ends for registration, for general registration. And the URL is on the bottom of the slide. Okay, end of my commercial. I'm going to start asking the questions. First of all, the slides, I will send everyone the slides as well as a link to the recording within 24 hours, if not sooner. And on to the other questions. All right, so the first one from one of our attendees is, what happens to cross-database transactions? Do they not replicate?
Oh yeah, so that's a good question. So they will replicate. The only thing is that if you have a cross-database transaction, I may not be 100% accurate, but I think it has to wait until all execution gaps before have been executed, and it will likely, so it will prevent parallel execution. So say you have two databases, if most of your queries are using cross-database transactions, multi-threaded replication in 5.6 will not help a lot. So you can still use it because it may help you a bit, but in general, it's not that useful. Okay, next question.
Let's see. Does multi-threaded replication also work with Percona XtraDB?
XtraDB cluster, I guess. So I'd say yes and no. So these are different things. So multi-threaded replication is about MySQL replication, and Percona XtraDB cluster works with Galera replication, which is a totally different beast. So and it already has parallel applying. However, what you can do is to have an asynchronous slave replicating from one of the nodes of the Percona XtraDB cluster. And in this case, having multi-threaded replication for the asynchronous slave can be helpful. This is where you can use it.
Thank you. The next question is, let's see here. Is there any way to have the threads work so that no database contention happens?
I don't think so. So database contention is not something that replication can have a look at. So the idea of replication is that it tries to execute the replicated events as fast as possible, but it doesn't know about internal contention. So no, if you have if with single-threaded replication you already have lots of internal contention, well, even if you're in a situation where multi-threaded replication would help, you'll probably be limited first by the internal contentions. So again, you have to test before you have to test to know if it is useful or not for your specific workload.
Okay, next question. For checkpoint position, what if MTR thread apply insert before creating table where it is inserting data? How does MTR checkpoint keep track of these transactions applying by different thread on the slave? I hope that made sense.
Yeah, I think so. Actually, I've never seen cases where when you have say conflicts because of the execution gaps, but I don't know exactly about the internals because it is true that you can imagine a situation where when you create a table, but this transaction is, say, skipped until the next checkpoint, and then you have a transaction which insert data in the table. So my guess, however, is that for a given database, transactions are still being replayed in order. However, the order is not the global order set in the relay log.
Okay, the next question is, enabling parallel threads on the slave should not impact any master behavior and performance. Is that correct?
Oh yeah, that is correct, because the only thing it changes is the way the events that are already stored in the relay logs of the slave are executed. So for the master, there is no impact.
Okay, next question. Are there any best practices for combining the performance schema status or a template which users can start with and customize based on their setup?
So not yet. So the tables in performance schema are quite new because it's 5.7 only. I assume that sooner or later it will be included in the sys schema, which provides a set of predefined views. I don't think this is the case as of now, but anyway, you can probably do that and suggest that for inclusion if you want.
All right, next question. Is there multi-threaded replication in 5.7?
Oh, I didn't hear the whole question, Alisa. Could you
Oh, I'm
repeat it?
sorry. Sure. Is there multi-threaded replication in MySQL 5.7?
Yeah, you have multi-thread replication from 5.6. So in 5.6, you have multi-threaded replication only when you have several databases, because each worker thread can only execute transaction on a given database. In 5.7, you have the same feature, but you can also use intra database parallel applying. So in 5.7, you should expect more benefit from multi-threaded replication.
Oh, the person said it was a typo. He meant, is there multi-source replication in 5.7?
Oh, right. Okay. So yeah, in 5.7, it should be there. So again, everything 5.7 is unclear because it's still being developed. I guess it should be there.
All right then. Are there any implications with regards to GTIDs and multi-threaded replication when running a master-to-master setup?
So there are implications if you run GTID replication. As I mentioned on my slides, the main one is errant transactions. So if you're running master replication, that's a bit different, because if you write on the slave, well, the slave is also a master, so the event will be replicated back to the overslave, which is the overmaster. So I guess you shouldn't have issues with errant transactions, but still be careful with that. And of course, the other thing is, if you need to skip an event, you have to inject an empty transaction. You can no longer rely on set global SQL slave skip counter.
Next question. What do you expect from MTS with logical block? Do you think performance would be good as with per database?
So in theory, it should be much better. It should be much better. So for instance, if you have a single database, it is clear that it should be much better, because even in this case with 5.7, you could do parallel applying, which you cannot do in 5.6. And if you have several databases, well, it should still be beneficial. However, in my slide, I didn't present numbers or graphs for 5.7 because I did a few benchmarks, and honestly, I was not convinced by the numbers I got. Basically, I got very bad numbers, and I should take more time to investigate. I'm not sure if this is because I misconfigured something, or because, well, it is still buggy because 5.7 is still under development. So in theory, I would expect a lot of benefit from logical clock multi-threaded replication in 5.7. But of course, again, we should wait a bit and do more tests to make sure that we have what we expect.
All right, next question. How does Percona Extra Backup work with MTS? What are the changes in MySQL dump?
So if you're not using GTIDs, it is tricky. It is tricky. So let's first talk about extra backup. If you're not using GTIDs, extra backup will rely on show slave status on exec master log post to record the position. So with multi-threaded replication, that will be wrong. With MySQL dump, if you're using the dump slave setting, it's exactly the same thing. That will rely on show slave status, and that will be wrong. So you should use GTIDs. And if you use GTIDs, it will be good. With extra backup, if you're using GTIDs, position will be recorded with executed GTID set, which is reliable, and it will not use show slave status. So that will work. And with MySQL dump, you should simply remove dump slave. And then MySQL dump will print at the top of the dump the list of executed GTIDs. And as it is the same on all servers, that will be enough to have the right replication coordinates. So in extra backup or MySQL dump, do not need any changes to work with multi-threaded replication. You simply have to remember that you should use GTID replication and you should use the right settings with MySQL dump, which is don't use dump slave.
Okay. Is there any inconvenience with memory or cache when using more workers than the number of databases?
That was basically the thing I wanted to test when I tried to use 50 parallel workers with only 2 databases. And the results were, say, mixed. So in the case where I had 50% writes on each database, I saw that the slave with 50 workers was a bit more efficient, surprisingly. But when I tried the scenario with 80% writes on one of the DBs, the slave with 50 workers was less efficient than the other. So it's kind of difficult to draw any conclusion from that. But I think the most reasonable recommendation is that you should probably use the same number of threads as the number of databases. And another question is, let's say I have 500 databases with writes on every database. Should I use 500 worker threads? I'm not sure. I don't know. Actually, it may not be that good because actually one worker thread is one thread running in MySQL. So if you have 500 worker threads running at the same time, that's 500 threads running at the same time inside MySQL. I don't think that's going to be very good. But again, I'm not sure. At least if you have a small number of databases, let's say up to 10 or 15, you should probably simply use the same number of worker threads as the number of databases.
Whoops, sorry, I was on mute there. We have time for a couple more questions. And let's start with, can you use MTS with all bin log format options?
Yes, you can use MTS with row-based replication or statement-based replication. There's no requirement there. The again the only change about multi-threaded replication is that you have an extra step before replaying the events in the bin log, which is you have a coordinator thread that will try to dispatch the work between the available workers. But then a worker thread is like the regular secret thread for single-threaded replication. So it is able to replicate any kind of event as usual.
Okay, and the last question for the day, and please don't worry if yours was not addressed. There are quite a few more. I will send these on to Stefan, and he will answer them in our blog. So the last question is, When using MTS without GTIDs, is seconds behind master from show slave status valid?
I think it should be it should be valid. So even if you have execution gaps, I think by default the checkpointing period is like 300 milliseconds, and the max number of transactions between checkpoints is 512, which means that the checkpoints are quite frequent, and the granularity of the seconds behind master is 1 second. So it should not have any impact. Now, of course, you have all the usual issues with seconds behind master, which makes it not always reliable. But I think that doesn't really change whether you're using multi-threaded replication or not.
Okay, well, that ends today's session. Stefan, thank you so much for a great show. You generated lots of questions, so I think the topic was very relevant. And thank you, audience, for attending. And we hope to see you in future webinars. We're posting quite a few new ones over the next few days. So check out our website and please do register. And with that said, I'd like to thank everyone for attending. Stefan, again, thank you so much.
Thank you, everyone.